All right, so we're going to leave the LV side of things and move around slowly to the transformer. So obviously this is some kind of ventilation, is it? Or what is it? More a protective thing?
It's more of a protective thing. It helps keep the sun off it, helps keep people away from touching the transformer. It just encases it nicely.
And I noticed this is a bunded area, so these transformers are oil based. If there's any issues, they've got an area to collect all the oil, and they hold a bit of oil, I'd say.
Yeah, they hold a fair bit of oil, so this bunding should maintain pretty much all of the oil inside that transformer should it leak.
Now, if we move around to the front.
Speaking about the leaking factor, you'll notice that we've got a water filter here. This is always left in the open position. The idea of this water filter is that if the bunding becomes full of oil, that this filter won't let oil through.
Okay.
Because we leave it open all the time for any rain. So if there's any rain in the area, that's going to land in the bunding as well. So to prevent the bunding from filling up with water, it'll filter through this filter and out onto the ground. However, if there's oil gets into this particular filter, it will clog itself up, restricting the flow of any further oil.
That's really interesting. So it's filtering something and then acting as a impermeable filter to another thing. Is that standard practice, or is that something that
Well, I've seen them on quite a few of these systems that have a built-in bunding.
Right, it really makes a lot of sense. Now, I notice here, this is the Danger Alive, the whole big 22,000 volt. And I mentioned to Ayuka before we started filming, look how many bolts. There is actually 28 bolts, and you can count them if you want to stop and freeze this video. And this is obviously indicative of how dangerous what's going on behind there actually is.
Yeah, we can't risk getting any water in there. So that is to pretty much hold that cover firmly against the seal for the duration of its life.
Wow. And because this is an oil-based transformer, you've got an oil thermostat.
So there should be oil pressure, oil temperature. There's a bunch of
oil level indicator.
And you'll notice the marshalling box to your right there.
I do.
This box here is actually connected to the main HV circuit breaker for this transformer. So if there is any issues with the oil pressure, oil temperature, it'll actually turn off the HV supplying it.
Ah, right. So it's got the smarts in there, and I noticed too that you've got some of this real. I don't know what kind of. That looks like a pretty heavy-duty conduit.
Anaconda.
Sorry,
we call it Anaconda.
That's called Anaconda.
It's a rubber-coated steel flexible conduit.
Aha! And I noticed also too, you've got full metal, flexible corrugated conduit, I suppose you'd call it. Now the rated capacity, I'm reading off the nameplate, but I do know it's 1,000 kVA, so they're not talking an NVA. This transformer is not big enough to talk NVA because it's 1 NVA, 1,000 kVA, 50 hertz. So I'm basically transforming 400 volt nominal into 22,000 volts.
That's correct.
Cooling method, Onan, which I'm not sure. Well, it's oil based, and the weight of the oil. Any hazard a guess? Come on, take a guess.
2030.
1,216 kilograms.
Oh, how much is in there?
Yes.
Yes.
So I thought, you missed it. And the total weight of it is 3.6 tonnes. So we're talking about a fair whack of weight. Now, we've got this enclosure here. This is pretty heavy duty. What are we protecting here?
This is the connections for the high voltage to the transformer. The cables come from underground behind this flashing. This flashing's been put here to protect them and prevent anyone from touching them.
Now, HV cabling, I mean, at the end of the day, cabling has a conductor. We know whether it's aluminium or copper. In this case, it's aluminium. But we're not talking XLPE and stuff like that, are we? We're talking 50 mil HV, isn't it? It's 50, yeah.
50 mil.
50 mil. And the actual cable, it's got a lot of insulation. It's a bit different from LV.
Significantly more insulation than a low voltage cable. Significantly.
It's funny when you see how small. I saw the cable last time, how actually the small the conductors are, but then you forget it's the current, it's running at 20.
Because the voltage is so much more.
The voltage is so much more.
Potential is so much higher. The insulation is so much more.
Now, one thing I'd like to point out, there's a lot of dirt and stuff because we still haven't got to the end of this project. And what happens when you're working on site with a lot of other people and other contractors, stuff gets dirty, there's stuff flying around. So a lot of this needs to be cleaned and made nice and hunky-dory, for want of a better word. Oh, let's move around a little bit more to this side here. And so we've got earthing here. We've got two, they're 70 mil, well that's 70 mil, that's 70 mil. The plinth looks 70 mil, there's 70 mil. That one's a bit small. And so that particular earth there is for the actual enclosure, isn't it?
It's for the flashing, yeah.
For the flashing.
So because we're on a HP site, all of the any metal component that can be removed at any time needs to also be earthed. So this is earthed with sufficient length that if you were to take that flashing off while the system's energized for any reason, not that you should, that cable can still be connected to that flashing, protecting you.
Yeah, right.